What is a phasor? No, not from Star Trek, that's a phaser. I'm talking about a phasor. Phasor is short for phase vector, and it's a complex number that represents a sinusoidal function. Complex doesn't mean difficult, it just means there's a real portion and an imaginary portion, like me, the square root of -1. Phasors are vectors because they're written as a magnitude and an angle. The magnitude describes the amplitude of the wave, while the angle describes its phase, whether the wave is starting as a peak or a trough or somewhere in between. Phasors are commonly used to describe electrical networks because they often have sinusoidal values that have the same frequency but different amplitudes and phases. If we didn't have phasors, we'd have to use a lot of messy trigonometry and even some brute force guesswork in order to solve for some of the values in electrical systems. But by converting into the phasor domain, we can make the calculation straightforward and then simply convert our answer back from the phasor domain to the time domain. So now you know what a phasor is and why it's such a useful tool. I'm square root of -1 equals neon rubindium, and this is your STEM dictionary.